You know why most developers completely fail at building AI agents? It's honestly pretty simple. They skip the fundamentals. They're out there copy-pasting code blocks from random tutorials. But the second the system breaks, and it will break, they have absolutely no idea how to debug it. They don't understand hallucinations or embeddings or how prompts actually work under the hood. Well, in today's explainer, we are fixing exactly that. We're going to build the entire architectural stack from scratch, taking you from bedrock API primitives all the way up to production-ready deployments. Look, if you skip these fundamentals, you are going to build broken agents. But master them, you'll be building rock-solid production-grade systems. Let's get into it.
Okay, let's dive right into this. Here's our definitive 6-step syllabus for today. First, we'll cover core LLM fundamentals, then we'll move right into LangChain and LangGraph. After that, we'll master retrieval-augmented generation, build some actual AI agents, plug them into the outside world with the Model Context Protocol, and finally, we'll harden the whole shebang for production.
Starting with Section 1, Core LLM Fundamentals, the absolute bedrock of AI. To build any kind of autonomous system, you really have to deeply understand the cognitive engine that's powering it. Large language models, things like GPT-4 or Claude, they aren't magic. Fundamentally, they're just incredibly powerful next token prediction engines.
And before you write a single line of agentic code, you have to respect the context window. A token is basically about 3/4 of an English word, and the context window, that is the strict maximum memory the model has for a single request, like GPT-4's 12K limit. Now, I really have to warn you about something called the lost in the middle syndrome. If you try to cram way too much into this window, the model will literally forget the instructions stuck right into the middle of your prompt. You absolutely have to treat this space as precious real estate.
Now, LLMs are great at reading text, sure, but to actually search and retrieve information accurately, we need the data layer. We use embedding models to take our text and convert it into high-dimensional math. These arrays of numbers, which we call vectors, get stored in vector databases like Pinecone or ChromaDB. This is exactly what allows us to instantly find semantic matches.
So how does that matching actually work? It's all about cosine similarity. This is a mathematical distance calculation, and it's how a vector database instantly knows that the words puppy and dog are closely related, even though they don't share any of the same letters. This specific math forms the absolute bedrock of semantic search. All right, moving on to Section 2, LangChain and LangGraph. This is our application layer, because once you understand those basic LLM primitives, you can't just keep making raw standalone API calls. You really need a robust framework to orchestrate them all.
LangChain is super popular for this. It provides these standard plug-and-play interfaces to link your prompts, your LLMs, and your output parsers into nice, predictable pipelines. But a quick word of caution from the trenches here. Please don't overcomplicate simple things. If you just need a single, simple API call, just use the native SDK. Save LangChain for when you actually need a complex sequence of events.
Now, what's really interesting about this next evolution is LangGraph. Standard LangChain pipelines are just straight lines. There's no going back. But LangGraph is fundamentally different because it actually allows for cyclic workflows. This is a massive game changer. It basically treats your agent's logic as a state machine, which allows the agent to loop back, track its own state, and actually correct its own mistakes based on conditional logic. Moving right into Section 3, Retrieval Augmented Generation, or RAG. This is all about giving LLMs a factual brain. So your agent has a cognitive engine and a workflow now, but it's still highly prone to hallucinating. To fix that, we bring in RAG. This is the critical layer that essentially forces the model to cite retrieved, private context before it's allowed to generate an answer. So instead of just crossing our fingers and hoping the LLM knows the answer, we intercept the user's question. We first query our vector database, pull the top 3 or so most relevant documents, and then inject those documents directly into the prompt alongside the original question. Because the LLM sees the hard facts first, we drastically reduce hallucinations.
Building this pipeline is a very strict step-by-step process. You load the documents, chunk the text, embed those chunks, retrieve them, and then generate the output. I really want you to pay special attention to step 2 here, chunking. You should be aiming for about 500 to 1,000 tokens with a slight overlap. If your chunk size is completely wrong, you're going to retrieve irrelevant garbage. And remember the golden rule of AI engineering. Garbage retrieval leads directly to garbage LLM generation. Every single time.
All right, Section 4, Building AI Agents. It's time to add some hands to the brain. We're officially ready to install that autonomous engine and upgrade from simple Q&A bots to true AI agents that can execute tools and actually affect the real world. The core architecture of an AI agent is essentially an infinite loop of 3 steps: perception, reasoning, and action. The agent perceives the input context. The LLM reasons about what its goal is and what to do next, and then it takes an action by executing external tools. Then, it updates its state and loops right back around to see what happened.
We call this specific pattern the react loop, short for reason plus act. But entering this territory is basically entering the danger zone. Agents need incredibly strict state management. Without proper constraints, timeouts, and tracking mechanisms, your agent can easily get trapped in infinite, extremely expensive failure loops where it just repeatedly tries and fails to do the exact same action.
So how does that action part actually happen? It's all through function calling. A big misconception is that the LLM is running your Python code. It's not. The LLM simply outputs a specifically formatted JSON payload that instructs your application environment to trigger a certain tool. Because of this, the LLM relies entirely on you writing crystal-clear tool schemas and doc strings, so it knows exactly what tools it has and how to use them.
Section 5, Model Context Protocol, the universal plug. Because to truly empower these agents, we need connectivity. We're moving up the stack here to introduce Anthropic's Model Context Protocol, or MCP. This is an incredible open standard that's rapidly replacing all those fragmented, proprietary plugin ecosystems we've been dealing with. And this brilliantly illustrates how it works. MCP is basically a universal plug. You set up an MCP server that exposes your local files, maybe a Postgres database, or enterprise tools like Slack and GitHub. Then, your LLM client connects securely over this standardized protocol. The beauty is, you write the integration once, and any compliant AI can instantly converse with your entire infrastructure. It's absolutely awesome.
Finally, Section 6, Hardening for Production, Fortifying for the Real World. I'm going to be straight with you guys. Deploying agents locally on your laptop is an entirely different universe than running them in production. Out in the real world, non-deterministic AI behavior and runaway API costs will instantly break unprotected systems. Building robust production systems requires absolute discipline. You absolutely must have strict execution timeouts set up so a confused agent doesn't just hang forever. And you absolutely have to implement retry logic for those 442 API rate limit errors, because trust me, you will hit them. It's guaranteed. Let's rapid fire some absolute mandates for production engineering. First, track your tokens and use semantic caching to save money. Second, implement exponential backoff and drop down to cheaper fallback models if your primary one goes down. Third, enforce strict input validation so you don't get prompt injected. And critically, deploy asynchronously using task queues like Celery or RabbitMQ. If you try synchronous deployments, your server is going to crash because agent tasks can easily take 10 to 60 seconds to execute. Do not let your server time out.
So here it is, the ultimate cheat sheet. This completes the entire modern AI engineering stack we just built together. From LLMs and embeddings at the bottom, up through LangGraph, RAG, MCP, all the way to async production deployments at the top. My biggest piece of advice to you? When things break in production, and they will break, trace your failures systematically back down through these exact layers.
Remember, skipping these fundamentals practically guarantees you're going to build a broken agent. But you now have the exact foundation that separates those weekend prototype hacks from rock-solid production systems. So I've got to ask, what are you going to build with this? Are you spinning up a coding assistant, a multi-step research bot, or maybe an automated customer service agent? Drop into the comments and let me know. Thanks for joining this explainer, and I'll catch you in the next one.